Okay, welcome you to another lesson where we'll provide solution to this given question. So here we are saying that find the equation of a tangent to the curve y is equal to x to the power 2 plus 3x minus 2 at the point 1, 3. So here we need to understand what they are telling us to find. They are telling us to find the equation of a tangent to the curve, meaning that y is equal to x to the power 2 plus 3x minus 2 is a tangent. Not so at the point 1, 2, meaning that this tangent, a tangent that we should find on the curve, they should only meet at 1, 2. Okay, so for you to find the equation of a tangent, the first step that you undergo is differentiating this curve. Okay, so where I will say that dy dx is equal to, when differentiating we make the powers to be the multiplier, so it is 2 times x to the power 2, then the powers will be reduced by 1 like this. Then we say plus, what is the power here? We have 3x, meaning that this x has a power of 1, meaning that 1 will become the multiplier, that is 1 multiplied by 3x to the power 1 minus 1. So we make 1 the power, the multiplier, then we repeat this term here, and after repeating we reduce the power by 1. Now what is dy dx of a constant? Dy dx of a constant is 0. So we say that dy dx is equal to 2x like this, because 2 times x, that is 2x, 2 minus 1, that's a 1, meaning that 2 has the power of 1, plus 1 times 3, that is 3. Okay, here this one we know that x to the power, we know that we have x. Now what is 1 minus 1? That is 0. We should know that any number, any letter raised to the power of 0, the answer is 1, meaning that this one here to just give us 1. 1 times 3, that is a 3 here. Okay, so next step we are done differentiating the curve. Okay, so after differentiating this curve, the answer that we have obtained, this one here, 2x plus 3, is called the gradient function. So now step number 2 is where we are going to find the gradient. For you to find the gradient here, what should we do? We should substitute dy dx with m. We know that the symbol for gradient is m, so m is equal to 2x plus 3. Okay, so where we say that what is the value of x here? Since we are saying that at the point 1, 2, meaning that 1 is the x value, then 2 is the y value. In this equation, for you to determine the gradient m, we substitute x with 1. Okay, so m is equal to 2 times 1, that is 2, plus 3, meaning that the gradient here is equal to 5. Mind you, we should know that a curve, the gradient of a curve and the gradient of a tangent are equal like this. Okay, so where we should know that the gradient of a curve is equal to the gradient of a what? Tangent. Now what is the next step here? Step number 2 is where we'll introduce the equation of a straight line, where we know that a tangent is just a straight line that meets the curve at one given point only. So where we know that a straight line is given by y minus y1 is equal to m open bracket x minus x1 like this. Now in this equation we can see that we have 1, 2, meaning that in this equation where there is y1, we substitute y1 with 2. Then gradient, we know that the gradient of a curve or gradient of a tangent is 5. So where there is m, we put 5. Then in open bracket x. Where there is x, don't substitute x with anything. We just substitute where there is y1 and x1. So where we know that x1 is 1 like this. Okay, so y minus 2 is equal to 5 times x, that is 5x, minus 5 times 1, that is 5. Now we group the like terms together, where I will say that y is equal to 5x minus 5. Now this one here too, when it crosses this side, when it crosses this equal sign, becomes positive this side. So y is equal to 5x minus 3. So this is the required equation of the tangent to the curve.